Hello, this video is to accompany Notes 7.4 and Homework 7.4, which pertains to more rules for what constitutes an expression that's been simplified. So let's get to it. In order to be considered simplified, we cannot have any radicals in the denominator. That also includes fractional exponents in the denominator because a fractional exponent can be rewritten as a radical. So if there's a radical in the denominator, then we need to remove it from the denominator. Removing a radical from the denominator of a fraction is called rationalizing the denominator. So that process is what today's lesson is on, is rationalizing denominators or removing radicals from denominators. Before we get into that, just a couple of other rules to keep in mind while we're working through this today. If I have a radical and under the roof of the radical is a times b, then I can rewrite that as the radical a times radical b. Or if I apply numbers to it, the square root of 5 times the square root of 3 is equivalent to the square root of 5 times 3, or 15. Likewise for dividing. If I have a radical and a fraction under the radical roof, like square root of a over b, that's the same thing as writing square root of a divided by the square root of b. Applying numbers to this rule would be something like square root of 5 over the square root of 3 is equivalent to the square root of the fraction 5 over 3. So let's take a look at our first example. This first example is actually a simple one you'll see in a moment, but I'm going to show you how to rationalize the denominator. So even though there's a simpler way to do it, just bear with me as I go through it because I'll show you how to remove the radical from the denominator. So the first thing that we notice here is that we can cross out the 5 over 5 because it equals 1. So that leaves us with radical 6 over radical 2, which according to the rule we just learned is the same thing as radical 3. However, what would happen if 6 were not divisible by 3? Like if it were radical 7 over radical 2. Well, in that case, we couldn't just do that as easily. So we're going to act like they're not divisible, and I'll show you how you remove the radical 2 from the denominator. But at the end of the problem, you'll see that we get the same answer. We're still going to get square root of 3 for our answer. All right, so here's our problem so far. We have square root of 6 over square root of 2. What we're going to do to remove or rationalize the denominator, to remove the radical, is we're going to multiply this fraction or this number by 1. Because we can multiply any number by 1 and it doesn't change the value of the number. But the trick is we multiply by 1 in the form of the radical in the denominator over itself. So I'm multiplying square root of 6 over square root of 2 by 1 in the form of square root of 2 over square root of 2. Because I'm multiplying by 1, I'm not changing the value of the expression. To multiply this, I just multiply straight across. So I can draw this on the screen here. If I just multiply straight across, I will get square root of 12 in the numerator, And in the denominator, multiplying straight across, square root of 2 times square root of 2 is just the square root of 2 squared, which is 2. So I end up with square root of 12 over 2. Now, as you can see, we've now totally removed the radical from the denominator. So we have met that requirement for being simplified. The only other thing we need to do, though, is square root of 12 has a hidden perfect square in it, so we need to simplify that. Square root of 12 is the same thing as 4 times 3. Square root of 4 times 3. So as you can see, I have a perfect square here, 4, or 2 squared. So that will come out of the radical. When it comes out of the radical, we square root it. The 3 here remains under the radical because it cannot be square rooted. So we're almost there. Now I notice that I have 2 divided by 2, which I can cross out because it equals 1, and I'm left with radical 3, which is what we should have gotten according to the simpler way we did it. So in other words, if I go back to this, whenever I see a radical in the denominator, I'm going to multiply that expression by 1 in the form of whatever that denominator radical is over itself. Here's another example. I have square root of 2 over square root of 27. So just like we did before, we're going to multiply by 1, but this time in the form of square root of 27 over itself. Just like we did before, we're going to multiply straight across, and I get square root of 54 over 27. And then 54 can be broken down into 9 times 6, where 9 is a perfect square. So the 9 will come out of the radical as a 3. And I will end up with 3 radical 6 over 27. And then one last step, you may notice that 3 over 27 reduces to 1/9. So my final answer for this one is square root of 6 over 9. Moving on in the notes. When we want to multiply 2 binomials, we're going to do the distributive property here. So just like in the past, if you saw, let's not use yellow. In the past, if you saw 2 times x minus 3, we would distribute the 2 and get 2x minus 6. Well, we're going to do the same thing here, except now we have 2 binomials multiplied together. So in this case, we have to multiply the x times the x times the 2, the 1 times the x, and the 1 times the 2. So we end up with, let's clean this up a little bit. So we will end up with x squared, because that's x times x. Now I'm going to do x times 2, which is positive 2x. Then I'm going to do 1 times x, which is positive 1x. And finally, I'll do 1 times 2, which is plus 2. Then I just combine my terms, because I have a 2x and a 1x, which can combine together, and I get x squared plus 3x plus 2. When we do this process, a lot of people prefer to use a mnemonic device to help them remember how to do it. And it is an acronym that is FOIL, F-O-I-L. And FOIL stands for first, outside, inside, and last. That's supposed to help you remember which numbers to multiply. I'm not a big fan of gimmicks like FOIL, but if that helps you to remember, then by all means use FOIL. As long as you remember that each one of these is going to multiply by each one of these, I don't care if you call it FOIL or whatever. All right, let's try an example from our assignment. So this is number 5 from homework 7.4. Remember, we need to remove the radical from the denominator. So I will do this by multiplying by 1 in the form of square root of 3 over square root of 3. If I multiply straight across on this, square root of 2 times square root of 3 will give me square root of 6 over square root of 3 times 3, square root of 3 times square root of 3 is 3, and that's my answer. That cannot be simplified because there's no perfect square that divides into 6. Sometimes when you are simplifying radical expressions, you'll end up with a binomial. So you'll get a polynomial with 2 terms. In other words, I have one term that is 5, I have the other term that is square root of 2. That's called a binomial. And when that happens, we have a different way that we handle removing the radical from that denominator. Here's how it works. If we have a denominator that is a binomial that contains a radical, then I, again, just like I did earlier, I multiply by 1. But the 1 that I multiply by is called the conjugate divided by itself. So here's what a conjugate is. A conjugate of a binomial is the exact same binomial, except we switch the sign that's between the 2 terms. So for example, these are conjugates of each other. I have 7 plus 2 square root of 3 and 7 minus 2 square root of 3. So those are conjugates. All that's different is the sign in the middle. Changes from plus to minus. So here's how we're going to do this. We're going to multiply our original fraction by 1, but we're going to use the conjugate of the denominator. So our original denominator is 5 plus square root of 2. So we multiply by 1 in the form of 5 minus square root of 2 over 5 minus square root of 2. So again, since we're multiplying by 1, we're not changing the value of the expression. Then we multiply straight across. So we're going to multiply 4 times 5 minus square root of 2, and then we're going to multiply these 2 binomials. Let's look at just the denominators first. So we're going to look at only the two conjugates, 5 plus square root of 2 and 5 minus square root of 2 multiplied together. So let's see what happens. When I multiply these together, and I use FOIL, which we talked about a few minutes ago, that means I'll do 5 times 5, then I'll do 5 times negative square root of 2, then I'll do square root of 2 times 5, and square root of 2 times negative square root of 2. Watch what happens. When I multiply all these out, 5 times 5 gives me 25. Then when I do 5 times negative square root of 2 for my O in FOIL, I get 5 square root of 2. Then when I do my inside times inside, I get 5 times the square root of 2. And then when I do last times last, I get square root of 2 times negative square root of 2, which is minus 2. Now I actually got these two signs. I actually did FIOL here, but it makes no difference. So this plus 5 square root of 2 is actually the middle two terms multiplied together. But notice what happens here is I end up with this and this that cancel out, because it's plus 5 square root of 2 minus 5 square root of 2. Since those two cancel out, all I need to concern myself with is first times first and last times last. That's why we multiply by a conjugate, because it makes these two terms in the middle disappear. It makes the radical disappear. All you will be left with is first times first, 5 times 5, and last times last, which you're multiplying radicals, but they'll go away because square root of 2 times square root of 2 is 2. Square root of 2 times negative square root of 2 is negative 2. So you end up with an integer. So remember, this was just the denominator that we're talking about. So when we multiply the two denominators, we end up with 25 minus 2, which is 23. So as we move on to the next step, this part is what we just did, except we only did the denominator, and we got 23. When I multiply the numerators, I'm going to multiply 4 times 5, and I'm going to multiply 4 times negative square root of 2, which you see right here. We'll use the distributive property, and we end up with this. So 4 times 5 is 20, and then 4 times negative square root of 2 is minus 4 square root of 2. And we're done at this point because there's nothing else we can simplify. We got rid of the radical in the denominator, and there are no fractions here to reduce. So this is our answer. All right, this probably seems complicated, but once you do a few of these, it's not that bad. Let's try number 11 from our assignment. So on number 11, I have 4 square root of 5 over 2 square root of 2 minus 2. So just like we did on the previous one, we're going to multiply by 1 in the form of the conjugate over itself. The conjugate of 2 square root of 2 minus 2 is 2 square root of 2 plus 2. So here's what we end up with. We multiply by 2 square root of 2 plus 2 over itself. Just like we did on the previous one, we're going to multiply straight across in both the numerator and the denominator. But remember that when we multiply the denominators using FOIL, all we need to do is first times first and last times last, because we know that the O and the I in FOIL are going to cancel out. So I already know that my denominator is going to be an integer, and it's going to be first times first. Well, 2 square root of 2 times 2 square root of 2. Let's write that down. 2 square root of 2 squared. What does that equal? Well, remember that the square applies to everything in the parentheses. 2 squared is 4. Square root of 2 squared is 2. So this equals 4 times 2, which is 8. So that's first times first. Last times last is negative 2 times positive 2, which is minus 4. So the denominator of this very ugly looking expression is just 4. I think I have a technical glitch here. Yeah, that shouldn't be there. So let's get rid of that. Okay, so the 8 minus 4 right here is our denominator. The numerator, I just did 4 square root of 5 times 2 square root of 2. Well, 4 times 2 is 8. Square root of 5 times square root of 2 is square root of 10. So that's this term times this term, but we are distributing, so multiply it also by 2. 4 square root of 5 times 2 is 8 square root of 5. So let's carry that to the next slide. Subtract the denominators to get this. And then I have just one last step. Perhaps you notice that this 8 and this 8 are both divisible by 4. So I can reduce this, and it ends up being, since 8 divided by 4 is 2, 8 divided by 4 is 2, the square root of 10 and the square root of 5 I can't do anything with. So my final answer is 2 square root of 10 plus 2 square root of 5. That about does it for this lesson. If you have any questions, message me on Remind. I will hold another video conference on Tuesday and Thursday. That would be the 21st and the 23rd of April to answer your questions. And if you like this video, smash that like button, subscribe, click on the bell to get notifications of all my updates. I'm just kidding. I don't care about that. Hope you guys have a great day. Stay safe, stay healthy. And that does it for me. Thank you.